Hello Algebra 2 folks, and welcome to Piecewise Functions and writing the equations of them. You will need the guided notes that I gave you in class, and if you take out your notebook and a pencil, we'll get started. All right, the learning target today, which you need to write down, is given a graph, I can write the equation for a piecewise function. So I will be able to, at the end of this video, be able to write the equation of a piecewise. All right, now example number 1. We're going to write the equation of this piecewise. Now remember, we had talked about what a piecewise is. It's multiple functions within one graph. And if you look at this graph, we have two functions happening. We have that function in the upper left-hand corner, and we have this function. So we have two functions happening. So what we want to do is we want to start by deciding what the functions are in terms of their equation. So I'm going to start with naming the function f of x, and we need the braces. So the braces here are going to tell us that we have multiple functions, and so I'm going to go ahead and start with the one in the upper left-hand corner. And if I notice, that's a line. And how do I determine the equation of a line? Well, I need y equals mx plus b. So I need the m and the b. All right, so if I were going to look at this graph, I would pick 2 points, and I would find the slope, down 1, right 1. So the slope is -1x plus, and then the b is the y-intercept. So where is it crossing the y-axis? The y-axis, it's crossing here at 1, 2, 3. Okay? Now what I need is my domain or restrictions. Okay? I need to know where that part is being graphed. So you can put the word if. If not, it's not a big deal. But I'm going to go ahead and just write it there so you get used to that. The restrictions or the domain. So what's the domain of this graph? So if we remember that little foldable, and we would say, well, this would run into an arrow, so we would be at -infinity all the way to 2. Well, I don't want to write it in an interval notation. I want to write it in inequality form. So if I'm going to write it using an inequality, I would say x is less than or equal to 2. Know that the interval would be -infinity to 2, and the 2 would be included, and knowing that it's included tells us it's going to be a less than or equal to. So this is the way I want you to write it, but this might be what pops in your head right away, this interval notation. Okay? Now let's graph the other line. Okay, what do I need? I need a slope. So I'm going to pick 2 points here. I go down 2, right 1, so that's -2. Okay, and then I need the y-intercept. Oh, but I don't have a y-intercept. Okay, well, I guess we're going to have to learn a new way to write the equation of a line. The new way of writing the equation of a line is called the translated form. Okay, now, remember what I talked to you about v's. We can use that translated form on any function. All we have to do is switch the function, right? So let's talk about the absolute value translated form. We had the a, which was really like the slope, right? And then we had the absolute value of x plus or minus h. So if it was plus, it was left, and if it was negative, it was right. And then we had plus or minus k, and that moved it up or down. So all we have to do with lines is take the absolute value part out and make them parentheses. And we can do the same thing. We can pick any point on our line. For a v, we had to pick the vertex. But for a line, we can pick any one of these points and put it in this form, and we have the equation of the line. So instead of trying to find where it crosses the y-intercept and work so hard to find those values, we can just use this translated form. So the a is like the slope. Well, I already got the slope. Okay, and now I'm going to use those parentheses, and now I can pick any point on this line. And I'm just going to go ahead and pick this point right here, which is 2, -1. So I went right 2, which means I do -2 because right and left is opposite, and then it went down 1. There is the equation of my line. Now if you want, you can distribute it. Get -2x plus 4 minus 1, -2x plus 3. This would be the y equals mx plus b form. But you don't need that. I'm telling you that if you can use the translated form to write the equation of a line, you do not need to use the y equals mx plus b form. So let's try to use the translated form from now on, because I think it might just be a lot easier. Now we also need to know what the domain of this function is. And see, it starts at 2 and it goes forever to infinity. And in my head, that interval notation would be parentheses 2 to infinity. And the parenthesis just means it's not included. So I would say x is greater than 2 without the equal sign. So that would be my equation for the piecewise function. So there's some useful tools that can help you when working with piecewise function. So one is knowing how to write domain. Now we know how to write domain in interval notation. So we have to practice writing the domain in using inequalities. So, you know, you might have x is greater than or equal to 8. Well, that means 8 to positive infinity. Okay? Or you might have x is less than 9, but greater than or equal to -1. So that would be an interval of -1 with a bracket all the way to a 9 with a parenthesis. So we want to make sure that you understand interval notation, but we also have to be able to take our interval notation and make them into inequalities, because we need to use inequalities when we do piecewise functions. Another helpful tool would be able to write vertical and horizontal lines. X equals a number, that means my, if I have a vertical line. Y equals a number, like say 5, that would mean I have a line that goes straight across and is constant and has a 0 slope. If I have a vertical line, I would say I had an undefined slope. And then these two are huge as far as the fact of knowing how to do those translated functions. And I just briefly talked about the linear translated function, but notice how there's some major similarities between linear and absolute value. Here we have a slope. This determines if you go left or right. So if it's negative, you would go right. And if it's positive, you would go up. Okay? If you have x plus h minus k, this would mean you would go left and down. Okay? But in all aspects, you just find any point on the line and you plug in your h and your k, and you have your translated linear problem. Okay? And then the absolute value, same thing. This is like our slope. Again, our h and our k are where our vertex is. Remember, so wherever you find your vertex, that's where you plug that in. So these are some very helpful tools, and so make sure that you have these written down so that you can utilize them. Okay, let's try another writing an equation of a piecewise. This time it looks like I have 3 parts. Okay, so I'm going to start by naming the function. You can name it anything you want. Doing your braces. Okay, this is a brace. And then doing the 3 equations that go along with it. Okay, well this is a line. So I need that translated line form here. Plus or minus h, plus or minus k. All right, here we go. Let's find the slope first. That's my m. Pick 2 points. Go down 1, right 2. So that would be -1/2. Find a translated point. You could use this point or this point. I'm just going to go ahead and use this point right here because it's the biggest point. -1, -1. Okay, so I have -1, -1. That means I went right or left 1, which means I go +1 and then -1. okay? And you can distribute that out and get it in y equals mx plus b form, but I am certainly okay with just leaving it like that. Now we need to know the domain, okay, or the restrictions. Okay, so the domain would be -1 all the way to negative infinity to -1, okay? So the interval notation would be -infinity to -1. So it's everything less than -1. So that would be x is less than -1, not inclusive, because that's an open circle. All right, let's do the next line. Okay, the slope of that line is 0 because it's a horizontal line, and it's a horizontal line at 2. So we're just going to say 2. There's nothing else that goes with it. This is a y equals line. Okay, so y equals 2, and that is between -1. This is -1 and 1, 2, 3. So x is less than 3, but less than or equal to 3, but greater than or equal to 1. So between 1 and 3 is where that graph is graphed. Okay, let's do one more here. That's this one. All right, and it too is a line. We need to find the slope. So pick 2 points, down 1, right 1. So down 1, right 1 would be a -1 slope. Find a point. Okay, so we can use this point right here, or this point, or this point. It doesn't matter. I'm going to go ahead and use that one. That one's 3, 4. So I went right 3, so that would be -3, and I went up 4. And then the domain or the restriction of this graph would be 3 all the way to infinity. Now that's interval notation. So a way to write that is an inequality would be x is greater than 3, knowing that I don't include the 3 because it is an open circle. So that would be the equation of my piecewise. Okay, let's try one more. So I have, if you notice, when I look at this graph, I see 3 different functions. I see a line here. My purple is my line here. I see a line for my red. Okay. And then I see blue, and that looks like a V to me. So I'm going to go ahead and graph these 3 functions, okay, over onto the side here. So let's go ahead and start with naming the function and writing our brace. Okay, and then go ahead, and I'm going to do the blue V. Now this is a vertex, okay? The vertex is -3, 2. So how do I write the equation of a V? Well, I need the slope, okay? So let's figure out the slope. Up 1, 2 over 1, so the slope is 2. It went left 3, which means I'm going to do a +3. And then it went up 2, which means I'm going to do a +2. Okay, where is that graphed? Well, that is graphed at -2 and below. So that would be, and I'm going to make this point the blue point, and I'm going to make this point be the purple point. And so I'm going to say it's included in the blue, all right? So if x is less than or equal to -2, all right? And then I'm going to do the red graph. Now again, that's a horizontal line, so it's a y equals, and that's at 1, 2, 3, 4, okay? And then that's between -2 and 1, 2, 3. So x is less than 3 but greater than, excuse me, I can't put the equal to there because I have the equal to up here. You can't have these both being equal or it's not a function. So you have to make sure that one is an equal, one isn't an equal. So I'm going to make the red one the not equal. And then we have the last line. which is this one right here. Okay, and it starts at 3 and it goes to infinity. So x is going to be greater than or equal to 3. Now let's go ahead and graph this line, or write the equation of this graphed line. So you got to pick 2 points. And I go down 1, 2, 3, and over 1, so it's negative 3. I can do the translated form. I'm going to pick this point right here. That's 4, 1. So I went right 4, so that's x minus 4. And I went up 1, which is plus 1. And that would be the equation of my piecewise. Now, you can break the v up into 2 parts. You can make this into a line and this into a line. I am completely fine with that. If that's what you visualize as 2 separate lines instead of a V with a vertex, go ahead and make your piecewise 4 different functions. I'm going to keep on doing the V's just so that we can see that, and then if you want me to help you break it apart, I am more than willing to help you with that. Thank you for taking good notes, and we will see you tomorrow.